So, hello everyone. Before starting off to that third problem solution, I know you are waiting how you are going to solve this question. It's a very amazing problem. We'll show you. Wait for a second. Before that, if you're new to the channel, we started a new OA series for you, all of you guys, and this is a very important series if you're preparing for placement and interviews. Do check it out. The problems are amazing. I handpicked these problems, made the solution, and explained the whole thought process, how to think in the interviews and the online assessment. Cool. So let's start with the problem. What do you think? Would you mind blown with this problem? Are not able to find the solution also. Then you come to this video, right? I know that. And myself was not able to do that. It was a good problem, but I will explain you in a very intuitive manner that how you can think about that. It's a learning problem. It's not like a very always kind of problem will keep occurring. It's not a pattern. It's out of the box problem that if you solve this, you solve the whole online assessment and you got the interview, right? This is this kind of problem. So we'll see what's the thought process and what are the things should come to your mind at least, and then how you can left some things and pick some things. Okay. So I hope you understood the question well, that it has a generate schedule problem. You're given an integer n and n teams you have provided, and you had asked to generate a schedule such that each team plays every other team exactly twice, one and home and once away. It's like an IPL match, right? Yeah, Chennai Super Kings, CSK, MI, and all. So they have one and home matches. I think it's derived exactly from there. I don't know like who framed this question, but it's a beautiful question of real life. I was also thoughtful that how schedule happens. It's DSA applied there as well. So you see there are many implications of DSA as well in real life. So there is exactly one match per day that happens in IPL also. It has two matches on Saturdays and Sundays, but we are ignoring the fact that schedule is. But this is the most difficult bit that like you cannot a same team cannot play consecutive day matches. Let's say CSK versus MI happened on let's say first day opening match, then it cannot happen that MI versus RCB happens. Okay, it does not. It won't happen. It cannot happen. They have to schedule in that way. If not possible, don't schedule the matches. There's okay. Return a. We have to return the schedule of the matches, and it's a zero-based indexing. I hope you understood the question. That okay, you have to return the schedule of the matches. Okay, what are the schedule of the matches? Who plays against whom? And what is home and what is m. So they already specified that it's not you don't need to specify any third parameter. The first team would be the home team and the second team would be the away team. Okay. So firstly, not thinking about the solution but reading the question, that what are the implication you can make. Okay, so there are n teams, you have to play with every other team. So number of matches would be NC2, but since you have to play two matches, one at home, one at not home, so away, so it's like n into n minus. So roughly of order of n square, right? But the interesting thing about the complexity of the solution, like n is still 50. That also gives some hint. I will tell you why n is 50, why it's what you have been if you have been 10 or what, then how your approach should change. But n is 50, you're definitely sure you cannot try out all the possibilities. The one thing that should come to your mind is trying out all the possibilities, because n is smaller, but will it work? No. Why? The trying out all the possibilities, the permutations, you can say that it would be like 50 factorial, or rather the maximum to 50 you can do some binary thing, but that won't suffice that, right? Cool. That won't also work. Then how do you think now with these kind of problems? How do you think? Cool. Recursion won't work, and greedy was not working initially. That okay, I tried. I also tried. Okay, making some patterns. Okay, can we make some patterns? Let's say I schedule 1 2, then I schedule 3 4, then again I schedule 2 1, and then I schedule 4 3. But it won't. It eventually, when you make certain example, this idea won't work always. Like this won't work if you make a very big tree. But a tree means all the schedule, all the messages, some conflicts will be there, right? Okay, that is fine. Means pure greedy won't work. What I do mean by pure greedy? Pure greedy means a particular algorithm, a particular pattern. It might happen, but it's initially not able to think. Okay, Now we are stuck. How to do that? Now here we'll introduce a very beautiful concept, that how to solve this kind of problems. Right. I hope you have solved the majority element problem. If you have not solved, do check it out. The problem, the majority element, it can be solved in two particular ways. That you, what the problem statement says is, you have a element which occurs more than n by 2 times, more than n by 2 times strictly, and then you have to find that element. That's all is the problem is. So yeah, you will say, that's a very easy solution. Just count the frequency of each element, which is the maximum, or maybe you can say n by 2 more than n by 2, just written that. Right, right, right. But we don't want to do with the frequency. We want to do it without the frequency array. So there's too many. There was some dash algorithm, some algorithm is there. We are not going there. There is another beautiful problem, beautiful solution to that problem. This problem. How? You pick an index that is a majority index. You pick this randomly. Okay, this assume this is your answer. This is your answer. And then what do you do? I assumed it, and then I told, oh, let's verify it. Let's verify it. Right. Let's verify it. And if it founds correct, oh, job done. I found my answer. Return it. Right. If not, retry. If found false means, let's say its frequency is not more than n by 2. Fine, no problem. Found less. If not found, then retry. How many retry? That's a particular question. This is fine. I hope you understood this. That let's say I have 1 1 1 2 1 1 2 3 2, this kind of array. Let's say 1 2 3 4 5 6 7 8. Yeah. So you can say one more element you can add. So you have more than n by 2 n's in there, I guess. Yes, they are. Okay. So you pick, let's say in the first go, you pick two. Okay. Then you checked how many frequencies there. No, it's not satisfying. Cool. Then you pick suddenly this. Oh, it's there. Return. Fine. Right. And now we'll calculate the probability that it won't happen. It won't happen means it is less than n by 2. That means half the probability. Right. I assumed it. It could be very large as well, but I am assuming, okay, if it is not happened, like we picked the wrong index, the probability is less than half, obviously. Not exactly, but let us assume at max half. Then I will repeat the same process 20 times. Then it is independent. It is independent. I am retrying 20 times independent, and its solution, the probability becomes 2 power 20. You know that it's approximately very, 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 very 0.00000 something like that. It's very small. You can negligible. It could happen when you submit the answer, it will fail. It could happen if you submit 2 3 times. It may happen. Sometimes it pass, sometimes it fails. It's a probabilistic solution, but solution on the same concept applies here as well. Now, could you think about the solution? I gave you a hint that, okay, how to think about that. Yes, if you've thought about it, yes, 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 you're right. What are you gonna do? You'll initialize with all pairs. Let's say I now initialize with adjacent pairs, with all pairs possible. Okay, what are the all pairs possible? That 0 1 1 0, I will arrange in the same line, no problem. 2 0 0 2, so on. I will create n into n minus 1 pairs. Fine. Obviously I know that this is not the answer. I know that. But what I gonna do is, this is our initialization, and then this is our retry loop, that how many times we retry. Let's say we'll do a retry of 10. You can do a 15 times retry as well. We'll see how much retry we can at max do. That defines our time complexity as well, because we have to do within that time complexity limit as well. Okay, so let's say I have this matches vector, right? Then what I do is, I have the matches vector. I have initialized with something. It's not the final answer. I'm seeing that it's not the final answer. Is initialize that, and then we'll shuffle that. There's a function shuffling. Shuffle shuffle the array. Shuffle the elements array. It will randomly shuffle the array. Fine. Now what we will do? We'll check. We'll check that whether it satisfy or not. Okay. But you will say, oh, this shuffling cannot define exact probability here. It might say, okay, 10 to 15 retries is very less. You are right. Then what I will do is we'll optimize this shuffle as well. We shuffle it and we're gonna check the adjacent. I hope you're getting it. We'll check this ith, I minus 1 with ith, whether they colliding or not. Right? If they collide, do I shuffle it again or do I do something else? That's an important question. That's a very, very important question. Right? So what we will do is very surprisingly, we don't gonna shuffle it again. If we found a collision. See, if we don't find a collision until the end, until the end, no collision, then to no problem, right? This is a valid match pair. Valid matches. Return it, no problem. As explained above, in the same way, majority element, right? The problem arises, a problem always comes that collision occurs. Collision means that the conflict, the same team comes adjacent, collision occurs. Now what do? You have two options, either to shuffle the array again, but that would be costly, right? That would be costly. You're doing an operation again, and it would it again help or not? We don't know. Shuffle the array, right? So we won't wanna do this. What we gonna do? We will find a further j that will be not conflicting, will be not conflicting with I minus 1. And we'll swap that. We will swap that. If we found that, we'll swap that. And if we don't found that, then it could happen that, right? If we don't found that, there are too many trees there. I will make the tree at the end as well. Don't worry. If we don't found that, found, then we'll again retry, shuffle the logic. I will show you the code because the code will also understand you better. And I'll also make a tree that how we're gonna work. Cool. See, so what we're gonna do? Okay. So we'll define a conflict vector. We'll call a conflict function. So sorry. What it will do? It will check whether the adjacents are conflicting or not. Right? So we just checking the conflicting or not. Fine. Also, we verified that okay, three won't gonna work already given the test cases, and you can also check four also don't gonna work. Right? We'll we'll start with five and all. We already assume that, right? Cool. Because it might happen that it can get random results, right? But yeah, we'll start with five matches and more. So this is the initialization step. I already explained you that you can initialize it anyway. Either you pick last, first, anyway, but you have to cover all the pairs, right? That's why ij pairs we covered that this also, but also I should not be picked with I. That's the only condition. So n into n minus 1. I hope you're getting it. All the pairs initially. Now this is the important thing. What we did, this is our retry array that attempt 0 to attempt 10. You can go to 20 as well. We'll see how much range we can go. We did a random shuffle. How much complexity does it takes? O of n, right? It's just shuffling the array. Fine. Then what you gonna do? That I explained you. That we gonna iterate in the whole array. We're gonna iterate in the whole array. We'll check this. We are verifying this. This random shuffle is valid or not. If there is a conflict, okay, we found a conflict. Let's suppose, okay, that is fine. We found a conflict. Then what we gonna do? We gonna go and then what we gonna do? Until the end. Until the end, we find an pair, will swap that if this matches of I minus 1 is not conflicting with sorry, matches of j is not conflicting with I minus 1. If does not happens, see, we're gonna keep pushing the j until it conflicts, and then when we reach here, we'll check two things. If already we are out of the array, that means we did not find any pair which is not conflicting with I minus 1. That means we return this false and we did a retry. Fine. This we did a retry. Or Else what we did, we just swap this pair with the j. We are till I minus 1 here only. Now we'll go to I and I plus 1. Fine. We're not till reach the end. We are not returning true here. Right? We are gonna swap this and swap with whatever particular element with that, right? And then again we are gonna iterate until the end. Now we'll check, we'll initialize a okay variable, right? We'll initialize it okay, and we'll initialize whenever we got until the end. That means this random shuffle won't have any particular solution. We have to retry only. That's the only the answer, right? So we make it false, we make it break. Otherwise, you don't make it break. If we keep swapping and we find a pair, we keep swapping, and then if we eventually find a solution when okay is not becoming false, return this matches. This is a beautiful question. I know that it won't come to your mind easily, but if you solve that majority element question and you've seen the solution, you can solve any other question if you're not able to think in that direction, right? Now let's try to see that how much attempt we can go. See, this is O of n, and this entire loop is, I think, uh, matches into and to matches, right? Like matches size. So you can say n square into n square. How matches is n square size, right? This is also n square. You can go, and this is n. Oh, this is also n square, right? But this is separate. You are doing, yeah. It's n square only. Yes. Yes, it's n square only. You do a random shuffle. No, no, no. Actually, this is plus. Sorry, my bad. This is plus. Sorry for the complexity. This is n square. So technically n power 4. Now you can multiply. So it's 15 power 4, right? So it's 10 is good enough. You can go with 15. That will be dicey, but yeah, 15 20 it's fine. So this is how you compute. You should go up to 10 power 7, right? This is the maximum you can go. Now let's see also one more thing. What is remaining? Probability of failing, right? You should know that. Then only you can conclude that a solution will work within this thing, right? Let's try to see the probability concept also. So what we are essentially saying is how we are calculating the probability that every team total matches are, let's say, of n square order. I'm ignoring the constants. Total, this is total matches. Okay. And then every team will play 2n matches around, right? Around. Actually, to 2 into n minus 1 matches they will play, but around, let's say they will play 2n matches. Fine. They will play 2n matches. Fine. Then what we gonna do is, let's say we find a conflict. We find a conflict. What we gonna do? We're gonna go for a swap, right? What is the possibility? What is the possibility that we will get we will get a bad pair again? Like complete, we keep swapping and then we'll get a bad pair. What is the possibility that this is a ith team, right? So there are two teams. You can say I can get a 4n bad matches, right? 2 into 2n, like one match of, I'm just assuming, ignoring the constant, don't care about the constant. 4n, and the total matches are n square. This is the probability, right? These are the total matches available, total pairs available, and this I'm obviously we are not considering the left side. I'm totally considering it. So I hope you are understanding that actually we are searching in the right side. This will be more less, but this is fine. Okay, this is n square, and the total bad. These are the bad pairs. Like this is the probability of failing for swapping, right? 4n into n square. So means for each retry, I am probability of failing is 4 by n, right? For like we are not getting it. You're getting it. We are after random shuffle, right? Before the conflict, before the swapping. Now what we are doing is we are doing a swap, and if we, what is the probability that all the swaps won't help this is m. How many swaps we will do, right? M is the number of swaps available. There are further elements available. M is the further elements available, right? And now this we are doing retry times 10 times, right? This would be very, very small if you think about it. This is M is going up to n square order. Okay. So it would be like 4 by n into n square power, you can say 10, right? So it will be very, very small. You can say that 0.0000. So it's very, very important. Again, let me just summarize what I told. that initially that total n square matches. This is 2n matches every team plays roughly. Every team plays. Okay. Every team. Now what we need to do, what will happen? Why there will be a conflict? There will be a conflict always, because when you are a particular thing, I'm talking about now not swapping, just simple random after random shuffle. What is the probability of a conflict? At least one conflict. There will be four and bad pairs. I hope you're getting it. Right? And then the total matches are n square. So this is the probability without shuffle, the probability of getting a conflict. Now we have to resolve it. That's why we are doing a shuffle. And now you're saying after each shuffle as well, we are not able to form a pair, like valid pair matches. That would be m times multiplication, right? 4n over n square. Basically 4n into 4n into 4n into m times. Fine. And m is the number of swaps available, which is n square order. And then you are doing this also for retry times. So I hope you're getting it. It's very, very, very small. So I hope you understood it. I also explained the probability. I didn't explain in very detail because I don't want to go in very detail. I just want to give you intuition that how its solution is working. You can try with 0, 3, 4 attempts. You will see the solution will fail. Right. So try to check it out and also tell me what's your attempt, optimal attempt you got it. So, and also if you like the video, do subscribe to the channel and make sure to hit the like button. Stay tuned for more such awesome content. Cool. Bye bye. And also make sure to see the web series.